next year's postcards.
Mm.
And it's up on the site already. We're all good to go. They're also
Oh, yeah, for the prize competition, particularly, yeah.
So we figured out the order.
Okay, yeah, because I have no
It's
idea.
gonna be
I don't even know. Yeah.
Trent is going first, and then Richard, who stepped out, I guess, is going second. And Hayden is going third.
Third.
So it's not in the order in the book.
Is it?
No.
No, in the back.
Yeah. No. Go to the day schedules. And has Rod showed up yet? We're still dragging the notes up here.
Saturday.
That's all right, so we go 1. No, it's opposite order. 2, 3.
All right, so yeah.
So Trent, Richard, AJ. He's also here. Nico is also here. Right next to him. But it's just one. Just one presenting.
All right, one presenting. So first we go to Trent, and then Spargo, which will be they have a team, but Dr. I've met a few of the Spargo people. Yeah, right here, right there. Okay, yeah. So I'm just going to introduce the company, maybe not so much the individual or whatever.
Yeah.
And
I try to pronounce it.
Yeah. Okay, and so we have how much time are they?
Does Martine want to say anything, or is not? I don't know if she wanted to.
Not really. She doesn't.
Oh, then you take all
Yeah,
time.
and she just
Okay.
You take whatever time.
This is a 4-hour slot, which we don't need to fill. We won't.
Right.
Typically, it takes about 2 hours to get through them all. Mm-hmm. I also have evaluation forms, which I'll hand out before we start.
Yeah. Should I wait till the end to give these out, or
no? They're in all their bags.
Yeah, they already got them. Yeah.
If they want them, they have them.
Yeah.
And I have pens and I have evaluation forms, so we'll do that. We'll get them in their hands before we do this.
Mm-hmm.
But
this is interesting. This year it started on my daughter's birthday.
Yes.
This year it ends on my son's birthday.
Yeah, we have to push it back. We just need more time to make it all happen.
Yeah.
And the conference is earlier.
Yeah, I think we should move the close date to like the end of the year.
But nobody does anything in December.
Right.
Yeah. So we wanted to give. Where's Rod? We got plenty of time. Right, I'll hand out the forms at the moment, the pens. Get those in hands. Yes, sir. Hand out evaluation forms here.
I'll just leave that like that then.
Doesn't matter. I will ignore their now. Oh, cool. I can't wait. We were thinking
Probably. I'm the skinny guy. Shaved. Don't worry, I'm gonna put it back on. Hey, good to see you too. You around all weekend? Or are you leaving? Or yeah, would love to catch up. Yeah, what you been up to? Pardon? Ooh, stratospheric balloon flights. Basically, think space agency talks. Yeah, yeah. No. Yeah, exactly. Yeah. I'll tell you, what do you need? No, this is the NSS here, or whatever. Yeah.
So they have USB-C, but they don't have HDMI.
Right.
We have a HDMI USB-C adapter.
Oh, wow. These guys might actually.
I could convert it. I got the laptop. So you're gonna talk for yeah, like do a little introduction, and then I'll call Trent up. And I think we're gonna need a minute in between each one for them to pull their You can hit F5 to turn it off. Yeah. I think we should get everyone filtered in, close the door, and yeah. HDMI 1. Yeah, it's up. It's up there now. It's up there now. Yeah. Maybe just.
I thought it'd be good to run out. This is like PDF.
Yeah. I'm not sure what. But in duplicate, we're seeing the same thing here and there. Yeah. All right, we're getting ready to begin. Everybody find a seat. This is going to be a packed house, so if we can try to move all the way into the wall, leave space. We are going to be certainly standing room only. We have some open seats. Try to move all the way over to the right towards the wall. Make room for everyone else to come in here. Closer. Yeah. This is the room. I don't even have to. Hello. Excellent. All right. The mic in the ballroom downstairs picks up everything in a 6-foot radius. This one, not so much. All right, excellent. So welcome. We are getting started here. Thank you for attending the Rothblatt Space Settlement in our Lifetime Business Plan competition. We have our 3 finalist companies here today to pitch to you. And we are really excited to hear from them and to ask some questions and a little background on this prize competition, sponsored by Martine A. Rothblatt here in attendance, who has, thank you, NSS Board of Governor, serial entrepreneur, and just an amazing human being and a very kind soul. So Martine was, generous enough to provide the prize purses for the finalists and has envisioned this competition as a way to stimulate, bespoke and novel concepts and ideas in space settlement. Despite the fact that we have been launching rockets for, coming up on 100 years this year. This next year will be the 100th anniversary of Robert Goddard's Nell. So for 100 years of rocketry, we have a very immature conversation around settlement. It's been, how do we get up? How do we beat them up there? But really no plan about where we're going and why and staying there. And Gerard O'Neill, who is an inspiration to all of us, certainly most of us, even though many of us are coming to an age, a time past his time, and maybe have never had a direct engagement or experience. He was eloquent and in his articulation that we could do this in decades ago. We could have done this decades ago. And for me, in my socialization into space, because of that perspective, I never saw space as a technical problem, because I always saw it as a social problem, that if we have the common will, there is no technical obstacle that can stop us. And so I've always seen that the real issues that we must solve on our course to space migration is winning the social conversation, and the technical challenges will be resolved through that. So here today we are beginning. We're in our 5th year of this competition, and we have seen just incredible growth of the people who've won this already. We've already seen a first place prize go to space. And so it has an incredible batting average in here. We've seen the amount, the quantity, and the quality of these business plans continue to grow, and we are excited to see and hear from everybody here today. And the first contestant, the first business plan that you're going to hear from is no stranger to this competition, no stranger to the National Space Society, and no stranger to the technical and social challenges of human space applications. Trent Tresh is an incredible person on his own. I've been thrilled to get to know him through the ISDC, and he is our reigning champion. Happy to have him back with another very insightful business plan. And so without any further ado, let me do a little house cleaning in here. We have ballots. So if you've not received a pen and a ballot, please raise your hand and make sure that we have them. You being a part here, you are going to be a part of the determination. These ballots are going to determine, the order. All three of these competitors have already won. First by applying to this prize, but by being here, all three of them will appear on stage. But this right now is going to determine in which order that we see that. So thank you for being judges for this competition. All right. So our first speaker is Trent Tresh, Stratolabs Near Space Experimental Balloon Capsule Kits. So put your hands together and welcome Trent.
Figure this out here. Hello, everybody. My name is Trent Tresh, as you've heard, and I'm here to tell you about Stratolabs today, my business that is focused on near space balloons. And so every year I come to the ISDC and I am enthralled by images like this one by Brian Versteg. They get me thinking about the future, our future in space. Now, I actually potentially somewhat disagree with Gabriel here around some of the issues in order to get us from where we are at currently to here. And I believe a lot of those issues are economic issues. And so I maybe like many of you actually have been beaten down year over year by headlines such as these that show space companies, whether they're for flight of ships to low Earth orbit or balloon companies, they just don't seem to be able to be in a place to deliver on a lot of their promises. And perhaps, really, we all know that space is hard, but I think space economics might actually be harder. So we're still trying to solve the problem of space access and technology. So with my background, about 10 years of spacesuit development operations, as well as being a balloon pilot myself, flying hydrogen and hot air balloon systems, and experience in manufacturing these types of systems, I figured that I would be able to take my experience and somehow encourage the ability to build a platform for space access and technology among the many and not just the few. And thus was born Stratolabs. Stratolab is a fully self-contained ground station, a mobile portable ground station that actually facilitates balloon flight. So every customer that purchases this can ship it on a boat, plane, train, automobile, right? And then can operate it anywhere in the world. Now, not only are they able to just operate their balloons, but inside we want to include the ability to manufacture. So here you see the ground station, of course, the computers, you'd have your radio systems and so on and so forth inside. This is what it would look like operationally in the field. But we want to be able to give them, our customers, heat sealing elements, training on such things. Now, the most exciting part probably about what I kind of deem Stratolab to be, which is a space agency in a box, is a fully certified 2-person space capsule to be flown to near space altitudes. So when somebody purchases this entire system, not only do they get to vertically integrate from operations to launch where they want manufacturing of the balloon envelopes, but they can not only do payloads, but also crewed flight systems. I'm very excited about that. And actually today I brought with me a handful of hardware items. These are all TRL 9s. So for those of you not aware of NASA standards, technical readiness level 9 is basically items that have been flown successfully in space missions. So everything up here you see is technology that would be included, right? Gear that would be included of this Stratolabs unit for the user, the end-based customer, to actually implement into their operation. So that's everything from emergency skydiving systems. We have aviation band radios. We've got oxygen systems, life support MBU-20 masks, regulators, ballistic cut-down devices for gear, your GPS tracking, radio tracking, even altimeters that can be jumped and skydove from space. So please do feel free to come up and take a look at these things as well. I did also bring one of our spacesuit gloves for you to potentially take a look at and maybe try on if you'd like. But we can supply all of this gear to really, again, enable the end consumer. We're no longer reliant upon these customers, or excuse me, these companies to raise the funding, to make promises, and then sadly go out of business. So why balloons? Now, balloons, to start off, I mean, there's a really long list as to why we should implement more balloon operation systems, but I'll start with saying legacy. Balloons are the oldest form of flight, started in 1783 in France. And I would actually even argue that they're probably one of the most reliable forms of flight. Both the US and Russian space programs for payloads and crewed systems actually started with these types of near space high altitude balloons. The cost of these balloon systems is 100 to 1,000 times cheaper to get something into the high stratosphere than, say, a rocket into space, including operations. Timeliness and location. With a system like Stratolabs, any customer can actually deploy these systems wherever they would like, whenever they would like, not having to wait on any satellite tracking times and coordination. Low carbon and carbon neutral systems. As you see here, this balloon actually is a polyethylene. I've got some examples of the polyethylene balloon materials that we have here that you're also welcome to come and check out, but it's 100% recyclable. Now, the lifting gases also, the lifting gases that can be used within these balloons are completely sustainable. So we have all of these positive aspects of balloon systems. Now, they get so high that we can even actually test technologies and operations for Mars. They're an incredible tool and an incredible analog to continue our progress technologically. And lastly, they can be flown by you. Yes, I want all of you to be here if you'd like. Of course, at these altitudes here, this photo is taken at about 120,000 feet above the Earth's surface. It's from a large balloon, about a 30 million cubic foot balloon, massive. So think like an 800-foot tall balloon, okay? Ballooning is not like fixed wing and rotary wing aircraft. In order to actually get certified, so let me tell you this, do we have any private pilots in here? So as private pilots, you need hundreds to thousands of hours depending on your goals for flights. With rotary. Ballooning, you need 10 hours of flight to be a balloon pilot, okay? Now at 40 hours of balloon flight, you are actually capable now of teaching other people how to balloon. So in about a week's time, I could take any of you in this room and actually make you a confident balloonist. Now let's look at some historical systems as far as gondolas and capsules go. Back in the 1930s, this is really the first time we went to high altitude stratosphere. Actually, the first photos even of the curvature of the Earth were taken from balloons by the Picards. So we had these aluminum and magnesium, which were called Dow metal spheres. They were pressurized spheres for two people. Incredibly difficult to manufacture, even to this day. I mean, generally in America, things are difficult to manufacture, but even now, just the tooling necessary to create a pressurized spherical system is phenomenally difficult. It'd actually add hundreds of thousands of dollars to our product if we were to sell it with that. So here behind me, what you actually see is a 1960s Navy system. So these are two Navy officers flying the Mark suits that were then later flown by Alan Shepard and the Mercury missions. So this was launched from a Navy vessel and then actually went to those near space altitudes above 100,000 feet and then landed in the ocean and was recovered. But what I wanted to show you here specifically is the two-person configuration and the simplicity of the aluminum design. Of course, the life support here is not by capsule, it is by pressure suit to allow the human physiology and consciousness to continue to work functionally normally up at those high altitudes. You know, these types of systems have even been flown by truck drivers. Here's another photo of the 1960s aluminum welded gondola for a single pilot here, as you see the different perspectives. This gentleman, again, was a truck driver, funded 3 flights to the stratosphere on his own, on his truck driver's salary over 50 years ago. So why can we not provide this capability today? With this inspiration, I actually worked with some engineers at the University of Arizona, and we were playing around with a handful of different shapes. And we wanted to make something that was as simple as possible to manufacture or enable other people to get their hands on and work with, right? That's part of our goal here is we want to give this technology to those masses to make sure that we can continue to develop. After running our finite element analysis, we came up with something quite simple and ended up building a fully certificated FAA experimental aircraft. So this is an aircraft that can legally be flown by a pilot and is something that we're currently playing with. Yeah, you see here just in a staging configuration, but it's going to be rated for 2 people. Again, as you see here, we'll actually have more side-by-side seats. You can actually choose as a part of the Stratolab configuration to have a open seated gondola or actually a pressurized cupola-styled gondola. We've actually even taken the system out into the desert and done hydrogen balloon standing tests as we get ready for some of our initial flights. So when we're talking about Stratolab, you know, we have this portable system, right? We have all this gear that's coming with it to enable further human space exploration and hopefully technological development for space settlement. But when it comes to not just the gear, every customer is actually going to get training from us as well. So because we know how to manufacture balloon systems, and these are any size balloons, these could be 5-foot diameter balloons, they could be 500-foot diameter balloons. You're really only going to be beholden on the space that you have to build these types of systems and launch them. Launching, by the way, doesn't need any infrastructure. That's another benefit of the balloons. You don't need a space launch system. You don't, I mean, you need a field, a beach, maybe a frozen lake, right? And so it can be done anywhere or just about anywhere. But once our customers purchase one of these container systems from us, they'll actually come in for training. Again, like I was saying, we can do balloon flight training in about a week. Whether you're using a parachuting system like this, that's about a 2-hour training to get anybody proficient in something like that, so on and so forth. So we'll schedule this time for manufacturing and for training to then to have that customer go and explore our world. Now, our costs in total are between $80,000 and $100,000 per unit. We're working on our first unit now. We can do about 1 a month at this point in time, so that's only 12 a year. As you can see, in about 5 years' time, if we do scale fairly conservatively, we're going to need to find a way to actually scale that up, but we're hoping to have our first sale this year through the Maldivian Space Research Organization. They're interested in this product. And every year we can do more and more, of course, about 5 years' time, looking at $5 million in revenue. Now, you might be thinking, well, you know, Trent, $250,000 for one of these things. Well, I'll tell you that that's about mid-range pricing for some of these ground stations. But I'll also tell you that, you know, our clientele or our customers that we're aiming for, our target market, we're looking at mostly government agencies, right? So the majority of government agencies don't have space programs, and if they do, they don't have any space capabilities, not to send payloads or even people. What we can do is not only sell to them, we've got universities, we've got maybe wealthy individuals who are pilots or even skydivers, but that market is still fairly small. So we start to think about, you know, what's our market segment look like and how long can we continue something like that? So if we actually dial back on our system, meaning if we take our Stratolab and we configure it in another way into just the ground station itself, we actually open up a lot of other opportunities. And so I want to bring your attention here to the global space economy chart. And we have these orange bars in the middle year over year. That's actually one of the largest segments, which are ground stations and equipment. This is from Haver Analytics. Of course, we want to verify that with the Space Foundation database. Here as well, we see the top 3 commercial space sectors, ground stations and equipment, constantly coming in at about $100 billion per year. Again, through Morgan Stanley, we see the same thing in 2016. We've got the blue area here, just over $100 billion a year, anticipated growth upwards close to $200 billion a year. Definitely much larger markets that we can enter with our base Stratolab configuration. And of course, this makes sense, right? Because a lot of things that we send to space, satellites, as well as what we would call stratolites on balloons, are sending data and information, right? Either they're providing internet service, communications, Earth observation, or remote sensing. This is what a lot of our customers are talking about doing with our balloon systems. And so if we can support obtaining this data and passing it on or processing it, well, then that opens up a huge market for us. And so, as I mentioned, each unit of ours is between $80,000 and $100,000 all in. If we actually take out all of the balloon configurations, the training, the two-person capsule, and just keep it a ground station by itself, we cut our costs by about 50% and grow our profit margin to that $250,000. Okay. Now, if we're able to capture just 1/10 or even 1/100th of a tenth of percent, a very small percentage, we can be pulling in tens of millions of dollars a year just from the ground station operations. Now, effectively, what that does for us is it creates a viable economic model to continue to support human space exploration and space technology operations for other countries, other individuals, other NGOs, and so forth. So I hope that I've shown you a little bit about our company here and convinced you that we have a viable economic system that can take space technology and give it to the masses, encouraging space access, and in the end, the goal being space settlement. Thank you for your time. And do we have any questions? Yes, sir, right up here.
I have a friend. His name is, I think you know them, Jane Fine.
Yeah, and Tabor, yeah. They just, I recently went out of business, it seems. Yeah. So just really quickly to add a little bit onto that. So there's a company called Space Perspective, right? And actually there, if I do this from the beginning, sorry guys, hold on. Shut down amid financial troubles. I don't know what is going on with them. So a lot of people have tried to start to explore the use of high altitude balloons. Again, we've been doing this for a long time. The US military used to use balloons fairly consistently, but these companies are trying to provide like launch and recovery services, right? So they want to be your luxury type opportunities for near space exploration. And the economics is, again, it's you'll hear me harping on this. That's, I feel, one of the most difficult aspects of space, and I don't think anybody is can escape its wrath. And so we're even seeing that here now. Companies that are raising hundreds of millions of dollars still aren't actually able to then end up delivering. And I think it also has to do actually with the level of scalability, because with a balloon system, you actually need a certain amount of lifting gas and a cost for that lifting gas. So in order to make your return on that gas, you basically have to have a capsule of a certain size. And the larger the capsule is, the heavier it is to lift. And you have this kind of logarithmic size scale of how big the balloon has to be. If you want to go twice as high, the balloon's not twice as big. It's going to have to be 20 times as big. So there are a lot of logistical issues with that. So I don't know. They're in hiding, it seems.
So, do you have any, I understand that the balloon itself is conventional technology.
Right.
It's not part of itself, right?
Mm-hmm. So, oh yeah.
So what altitude, what is your maximum operating altitude? Do you have concerns about traffic weight or radiation?
Right. So your float altitude, I mean, ballooning is based off of Archimedes' principle, right? And so it's displacement. And so just like in scuba diving, the higher you go up, the more weight of air you have to displace. And the higher you get up, the less and less dense the air actually is. So right now with modern manufacturing capabilities, the maximum balloon diameters are around 800 feet. And so you can take well, let me actually put it this way. So NASA right now still uses balloons through the Wallops ballooning facility out in Fort Sumter, New Mexico. And they're able to fly like 2,500 pound or over a ton on like a 600-foot balloon, which is something like 30 million cubic feet. So that's kind of the limits of manufacturing, and it takes time, right? So one of the balloons that I actually showed you that was connected to our certificated aircraft, it took me an hour to build, okay? But if you wanted to build a more robust system that is that big, that could take 6 months to build, right? And so you're limited on your manufacturing capabilities. But the float altitude's more or less, high altitude skydiving record is 136,000 feet. Yeah. So regulatory issues. So these systems will actually be experimental aircraft. So experimental aircraft mean you have to be a pilot to be able to fly them. If you were doing that, as far as payloads go, you have to file a NOTAM with the FAA here in the US and basically let them know that you're sending a payload. But if you want to fly it, you have to be a pilot. Now overseas, that obviously changes, but a lot of places overseas actually recognize the FAA as an authority. So if we certificate like we have with our balloon system here, we can then actually sell that overseas. And then if a pilot wants to, they're able to fly that overseas as well.
How much is what type of gas do you use to fill the balloons, and how much does it cost to fill them?
Yeah, good question. So consumables are not included like in our prices, right? We're providing the tools for people to be able to use for development. And so whether you're using oxygen systems, like with oxygen masks, you'd have to pay for that, and then lifting gas as well. Helium is actually quite expensive, and it's dang near impossible to actually buy unless you have a contract. So we like to use hydrogen. And hydrogen is actually flown safely around the world every day. That's what I've only ever flown as a gas balloon pilot. And all of those photos you see with gas balloons were all hydrogen. And basically to do about, to fill that 30 million cubic foot volume that could get you to float altitudes close to 140,000 feet, you're looking at about $20,000 a flight. Yeah.
So do you see any differences between your ground station for balloons versus
Yes.
what you need with orbital velocity?
Mhm. Well, yeah, definitely. So your ground station, I think, is going to be more so based off of what type of communication you're transmitting, right? So if you're C-band, KU band, but remember with our system, what we're able to do is we're getting rid of all the balloon infrastructure for that second configuration. And so we're actually saving money, even though we're buying all that additional equipment to provide for those new bands. Yeah, back here.
Great job. Awesome courage to get up there in front of all these people.
Thanks.
On the slide with the revenue, you got that one?
Yeah.
Just had a quick question. I think I love that you're conservative on the amount of units. My question is to why every single year you're keeping the price the same?
That's a good question. I don't have an MBA, so I'm still learning. Yeah. Yeah, actually, I think it might be something, and maybe other folks in here too, but like my generation, it's this idea of, how do we just make things as equitable as possible so everybody can, like have access. And that's not always a really good business model. So I know that I definitely struggle with that a lot of times, is just thinking, well, what do I have to do to just give this away for free so people can use it, right? But then again, I still have to eat at the end of the day. So what do you recommend? 10%, 30%, 100%. Thank you. Other questions? Yes, sir.
So I'm glad you took the other slide off because that's core killed my basic.
No. Oh, wait. Are you Orbital Outfitters? Who are you? You know Peter Homer? You know Peter Homer? Peter Homer. I work with Peter. Yeah, right here. Yeah, he is amazing. Right, we're selling the... Right. Definitely. Definitely. And that's something else that I know I've struggled with over the years, because you want to do everything, right? So what we're selling, right, is this self-contained unit that contains all these good materials, and then we train people how to use it. So we're selling the unit, and then training comes with the unit. Okay. We're selling the unit. Right. Right. Yeah, thank you. Next to you.
Yeah, I was going to say the same thing. It actually, if I were looking at your plan, I would say your innovation is being able to build a tactical ground station for a low price.
Right.
Assuming that you can.
Mm-hmm.
Right. And that ground station can receive satellites and remote control aircraft, drones, balloons, whatever.
Definitely.
The balloon is a demo.
Mm.
Right? The balloon is like a demo of using the ground station, and the business is building the ground station and shipping all over the world.
Right. Yeah. I think something though too that to keep in mind is that the goal here being human space settlement, right? So we're looking for profitable avenues to also engage then humans in space. And so I think again, that's something I appreciate the feedback, but trying to figure out how to actually. Yeah. Of course. Yeah. The economics of space is hard, right? Of course. I understand. Thank you. Oh no, I'm sorry. Over here, yes.
Is there companies that are doing the same that you're doing at this point that are not bankrupt? And are they closer to the market?
Not that I know of. So the business model that I've seen done currently with balloons that has seemed to cause some problems is you build the balloons and then you sell your services, right? Your launch and recovery services. So like a Worldview, for example, they're building the balloons. They're either taking the Stratolite payloads or helping develop those payloads and then providing that service. And a lot of those contracts are government contracts as well, right? Like a lot of things in space. So a lot of their funding is coming from defense, NASA, and so on. But that's not the model we're trying to do, right? We're not trying to sell the service. We're just trying to sell the product that people then can use as they'd wish. So like we're selling the car and you can use the car however you want.
So please correct me if I'm wrong, but it's not a closed unit, right? Like a capsule.
Yeah, good question. So sorry, continue and then I'll answer. Yeah.
From that, like I wanted to ask if it's not a closed unit, like what experiments or research can be done then? Like will it mostly have to be physical experiments or practical?
Yeah, good question. So I know NASA actually has, like a student ballooning program, and actually a lot of universities have ballooning programs too. Smaller though, you're usually using like inflatable latex balloon systems. You can do a lot of different types of things. You can do remote sensing. You can do optics. You can do little, people send up telescopes on these things. We actually first learned about cosmic radiation from balloon payloads. So there's really a lot of things that you can do. But let me go back to your first question about the balloon capsule itself. So right now, in the photos that I've shown you, the capsule is not fully enclosed. But actually what I'm playing around with, I'll give you guys a little bit of an inside scoop, insider baseball. We're actually, because of my experience designing spacesuits, we're actually going to incorporate spacesuit fabrics into the sides of the capsule because we actually only need to operate, we'd like to operate target between 3.5 and 5 psi inside of the capsule. Ideally a sphere or cylinder type shape is the best for internal pressures, but with such low pressures, our previous test has shown that we'd be able to do that, and it would actually be a significant way to cut out like the need for, say, pressure suits, right? Because pressure suits are expensive. Another question over here, sir.
Yeah, have you given any consideration to legal implications, particularly around export control? I think you might run into ITAR pretty quickly.
Yeah, definitely the case. I think it's, again, case-by-case basis, country-by-country basis. I don't think I'll be working with China anytime soon. But, yeah. So yeah, you're definitely correct, and we would see ITAR, not around, let's say, like life support stuff, but definitely radio stuff, right? So that is a huge consideration. Good thing, I mean, the U.S. is the biggest market, has the biggest market share, something like 70% of ground stations right now. So we'd probably have to figure out ways to work around that. As you can probably see here, my passion is about the human space side, but the economics tell me that it's the ground station side. So it's hard to bring those together. Yeah. Yes, sir.
Drone control nexus in a contested arena.
I haven't. I'm not a huge drone guy, but that's definitely something that I can, plug in here. If you want to chat afterwards, happy to do so. But thanks. Yes, up here.
So my question is more encouragement would be, who's your ideal customer avatar? And working on that, is it
Right.
really popular? This is a farm cooperative for
Yeah.
very hyper-regional weather forecasts
Yeah.
that you can't get from other people, and therefore that's how you look at your
Right.
revenue, is you work backwards from the value that you're creating for them.
Yeah,
And
no.
they save the harvest because they know it's for the rain.
See, there's that MBA insight that I was looking for. Now, those are great insights. Again, my interest, I want to see us living and working in space, right? And as of right now, 196 countries, give or take. There are about 47 countries that have had representation in space as far as astronauts go. But when you actually look at the impact of those things, I mean, still less than 1,000 people have been into space or even near space altitudes. Just with my experience as a pilot in manufacturing with suits and life support, I just felt that this was a way that I could contribute to try and get more people the hands-on equipment and experience necessary to continue development. Because what how does it go, Gabe? If you want to go far, go together.
If you want to go fast, go alone. If you want to go far, go together.
And so you're right. That's I do struggle with that on the business side. But anything else? No,
Yeah. Let's get the last one to David, and then we'll
David.
So what's consumable in here? What's reusable? What's consumable? What does it take to fly in the balloon?
Good question. So as far as the system, when we ship a full container to a customer, it's going to contain about enough polyethylene, which is the balloon envelope material, to build a bunch of smaller balloons, say like a bunch of 30-foot balloons, or mostly upward to like one single 800-foot balloon, right? So a pretty good sizable amount of polyethylene for that. But once they run through that, they'll obviously have to purchase. They'll have to purchase the polyethylene. The lifting gas itself is a consumable. And then if you're doing crewed systems as well, like oxygen, 100% aviators breathing oxygen is going to be necessary. And this also doesn't go to talk about like support vehicles. So, if somebody's going to need a car, and then the gas and things that they would need to recover their system. But yeah, everybody, if you do have more questions, I'll be around here all weekend. So I would love to chat with all of you guys and get to show you some of the cool stuff that we're working on here and whatnot. But I do appreciate your time, and we'll let these other guys jump up here too. So cheers.
Excellent. Thank you, Trent, and a great presentation with Strata Labs here. So you all have your ballots. You can feel free to begin scoring them as we go, or wait till the end if you so choose. And so we are going to need just a couple minutes to transition between each team as they come up.
There's water up here.
And we do have water, up here as well. So also thank you for the engagement, the great questions from the crowd. So let's give a little Shark Tank to each team, and really that the feedback on these presentations is invaluable. They'll all walk out of here with a check, certificate, credibility behind their ideas. But the minds in this room, the questions that you ask, are going to allow them to go home, to rework their plans. Beautiful questions and ideas in here, and we just lightly touched on it, but I think we all can acknowledge the elephant in the room of Chinese using balloons to fly over rapidly and increasingly. So very, very interesting to see where this is going to go. All right. So the next team coming up is the Spargo in-space propellant depots. And so we have Dr. Richard Niederlander. I hope I said that right. And Dr. Zhang and Mr. Pagalawan. I'm not sure I'm saying that right. But Spargo is the next company up. This is a refueling station in space. This is their first time in the Rothblatt Space Settlement Business Plan competition. But as it seems like a very practical idea. When the automobile was first invented, it was clearly an intriguing invention, but like many technologies, people questioned it and said, well, that looks great, but where are you going to get gasoline? And nowadays it's everywhere. It's on every corner. But you can imagine 100 years ago, that was not so. There weren't refineries. There weren't gas stations. And so those vehicles did seem rather impractical, but we very quickly adapted to it. I'm an EV driver, and I think we've seen how rapidly car charging capabilities. And again, when EVs first came out, people were like, "That's great. Where are you going to plug it in? Where are you going to get the power?" And already, that problem is solved. So necessity is the mother of invention, but sometimes you need the infrastructure in order to get there. So I'm going to. I think we have it up here. No, you've got it on yours. That's right. All right. So why don't you come on up and get started? And let's give a big round of applause for Spargo. Are you presenting just all right. Okay. Yeah. It should be. It's all right. It's switching sources. There we go. Let's go. All right, there we go. You want to? Excellent. Okay, one more time for Spargo, and thank you, and let's give him some good questions as well.
How do I turn that off? I have a microphone here. Just to avoid any echo, 2 microphones. Anyway, good afternoon, everyone. Thank you all for being here today. I'm really excited to be presenting the next big space venture, Spargo Space Corps. Our mission is to provide in-space refueling for space missions. Basically, you can think about it like gas stations in space, except the standard in space is 20 million per refuel, and on Earth, we haven't quite gotten there yet. So our team consists of 3 people right now. I'm the CEO. I've worked at NASA's Kennedy Space Center in their Deep Space Logistics program, providing space environment expertise for their logistics module contract in support of the Gateway. I've also worked at Blue Origin as a radiation effects engineer, and I've received my PhD in electrical engineering from Vanderbilt and my BA in astrophysics and music from Columbia University. John is our automations engineer. He has received his MA from engineering, an MA in industry management from Middle Tennessee State University, as well as a BA in astrophysics from Fisk University. And he's worked at Amazon as an automation engineer as well. And Ava is finishing up her PhD in computer engineering with a focus on computer vision from Stony Brook University, and has received her BA in physics from Wesleyan University. So we're a very knowledgeable bunch. We have domain experts in all the fields necessary to get this going. Boop. Yeah, so as we all know, we strongly believe in this. Okay. As we all strongly believe in this, by the 2030s, we are going to have space settlements on the moon and Mars. This is happening because the cost of launch is dramatically decreasing as we see more and more innovative rockets getting launched into space In the past, we had Falcon 9, Starship Heavy. Now we're having Starship, and we're going to have New Glenn, and who knows what else we're going to have. And what's really exciting about this is we're going to also have people on these settlements. We're going to have tourists, we're going to have the pioneers, the business people, and they are going to bring their business acumen. They're going to bring industry, they're going to bring construction, and they're going to develop these huge ecosystems generating tons of revenue. But in order for such an ecosystem to exist, it's missing an integral component, and this cannot work without it. It is the supply chain of in-space fuel. The reason for that is a lot of these spacecrafts just will not have enough fuel storage in order to get to their final destination. Starship even needs to be refueled in order to get to Mars. They're talking about trying to refuel itself with another Starship just because of that distance. So you can't just imagine that with the other spacecrafts. Like, how else are they going to get to these faraway distances, Moon, Mars, even beyond that? So with that, that's why we are developing our prototype of the in-space depots, because we want to enable these spacecrafts to reach their final destination. But not only that, we see an immediate need for this refueling because there are satellites right now that if they don't get refueled, they just get thrown away. They get sent to the graveyard orbit. And that's essentially can be upwards of hundreds of millions of dollars of loss when you can just get it refueled for 20 million or 15 million, and you can extend your life for 5 more years. Yes. So our prototype will be called StarVault. StarVault will provide a variety of in-house services that we are developing ourselves. The main one that we're focusing on right now, it is the lowest threshold to achieve, is this autonomous stocking and berthing software, which will be using vision language modeling in order to recognize docking ports of various spacecrafts in order to control the spacecraft and dock to it, provide the refueling, and then depart. We also have a partnership with Avalanche Energy to incorporate their nuclear energy technology into StarVault, enable nuclear power and propulsion. And finally, we are developing technology to enable long-term storage of propellant, because another issue is the longer you have this propellant in space, it slowly goes away, so you may not even have any fuel after a given amount of time. As I said, so our strategy is centered around StarVault, and the reason for that is this will be our in-orbit fueling depot. Our goal, long-term goal, is to mass produce them and make it scalable so that they are strategically located in the orbits necessary for the spacecrafts and rockets are expected to lose all their fuel and need that final refuel to get to their destination or to extend their mission lifetime. And as we get 5 years into the future, 10 years into the future, we'll be achieving economies of scale so that 20 million may end up being 10 million or lower. So here is a brief case study. Imagine you have a commercial GEO satellite. The satellite cost around $150 million to build. And the lifetime had 15 years. You're at the 15-year mark. It's about to die. Without refueling, it would just, that's it. You lose it. You may even have to spend a little bit more money to get that spacecraft, that satellite, off into the graveyard orbit. But with refueling, as I mentioned, we can get it down to 15 million, and that could potentially add 5 more years of life. Ultimately, you're avoiding building a new launch and launching a new satellite. And I've calculated the return on investment here, and that is approximately 900% return on investment just doing this. So our potential clients, there's a variety of GEO satellite operators currently out there. They include Intelsat and Viasat. We have newcomers like Astranis, and I'm sure we're going to see tons more going to the future. We have the space and defense agencies such as NASA, JAXA, but also the Space Force. And as we've seen from the White House's budget, they have increased a priority on landing people back on the moon and Mars. They specifically devoted $1 billion to making sure that we get back to Mars, or get to Mars, maybe. And we also have the space infrastructure builders. So this includes Orbital Reef or Sierra Space's Life modules. These are space stations that will also require refueling because I'm sure they don't plan on having them burn up and then having to rebuild the whole thing. So we are, as I mentioned, we are developing this proprietary autonomous guidance navigation software. This has been submitted for a NASA SBIR Phase 1. We're awaiting results sometime late July. This is the image that we provided to them demonstrating the whole technology workflow for it. Essentially, we have a vision language model that has been trained on various docking ports specific to that docking port. And it also will be able to recognize degraded environments so that if the images aren't the best, they can still dock properly. And it'll be built off of NASA's tech stack called the Core Flight System. Together, that's going to work with the hardware, which is an embedded AI computing platform, which will be radiation hardened, radiation engineer, and include a stereo camera, 3 of them for triangulation for distance, and thrusters. And then finally, we will get the spatial perception, feature identification, everything you would need to ensure that the spacecraft reaches the place that needs refueling. So as I mentioned, we have received some support so far from startups. Avalanche Energy has signed an LOI with us to provide insight into their tech in order to enable this nuclear propulsion, nuclear power for our spacecraft. And what's really interesting about Avalanche Energy is their founder is a former Blue Origin engineer. So I worked at Blue Origin before. We had a nice relationship. We talked a lot. So it's really phenomenal. They're helping out here. And to help with the training of our large language models for the VLM, we've signed a LOI with Horizon Compute, which owns thousands of GPUs, and they're going to give us preferential access and discounts on these GPUs so we can make these happen, this training happen as fast as possible. And this is the animation that they provide on that. So since being founded in 2025, this has only been around since January 2025, we've joined a wide variety of startup programs in order to provide us with the tools necessary to develop out Star Vault, as well as the basic foundation to make sure that we can quickly onboard new people as we raise more funds and start developing out the prototype. We've joined NVIDIA, so we also have preferential access to their GPUs and discounts. We've also joined the Cosmic Consortium, which is an aerospace group focused on companies specifically building out space mobility technologies. So this is a $115 billion opportunity. And this is based off of looking at how much the space economy is going to be in 2040 with your $1 trillion economy, as well as the increasing number of spacecrafts needing refueling. As I mentioned before, the cost of each rocket launch is drastically decreasing, which makes it more accessible for startups and companies to launch and ultimately realize they do want this refueling so they don't have to start from the beginning each time. And our goal, based off of our analysis, we see us charging $15 million per refuel, which is actually 25% lower than Orbit Fab because of our reliance more on autonomous navigation and less on these ground stations. And then ultimately, if we were to capture 30% of the market, we would be able to net $34.50 billion per year. So this is how we came up to the number for the 15 million refuel. This is part of it since it wouldn't fit the whole thing. Fuel procurement and storage. This is how much it would cost for us to procure the hydrolysine and to store it. Then we would have cost of the logistics itself, so the software, running the software, maintaining it. Then another mission planning and operations, at most 1.5 million. And then profit margin, we can get pretty high, so 30% to 50%. So ultimately, we could get as high as 5 million per refuel. So we have both a short-term and long-term revenue because we want to make sure that our investors can make money off of our what we're doing right now. We already do have an investor, which I'll mention later. The first short-term revenue stream is leasing out the autonomous software. So a lot of there's a really high threshold to developing this software. It's very difficult. You have to make sure that not only that it can work, but that it can work in space. And those two often don't align. Working at NASA and Blue Origin, I see this all the time. So that's what we'll be doing, and then we'll be able to lease this technology out to other spacecrafts, companies, and generate revenue very quickly that way. We will also be competing for government contracts. These include the SBIRs as well as OTAs and other grants. And then finally, the long-term goal, as I mentioned, is the fueling services. So we are new, and there are other competitors, but we strongly believe that we are going to leapfrog over these competitors because they're stuck in an infrastructure and a mindset that predates this AI autonomous world. This technology is going to be really hard for them to begin incorporating computer vision autonomous navigation into their design when they're stuck into a specific hardware framework. Given that we're totally new, we know we can change anything we want at this point. We can quickly adapt to whatever new trends are happening right now and make sure that we cut costs wherever possible. So this is our game plan. I've structured it in terms of mission design phases based off of how it's just done in the space companies. Our pre-system design review is going to happen by the end of 2026, where we are going to have a prototype of the software, miniaturized version of Star Vault, and we're just going to try to bring the two together and try to test it out in a parabolic testing to see if it can work in a microgravity environment. From there, we'll then continue with our simulation models and prototyping of everything. And then preliminary design review, we're going to try to finish this hardware in the loop, testing of all aspects of the space logistics modules. And then finally, complete construction by 2029 of the whole Star Vault, and then launch, hopefully on a New Glenn by then, but maybe Starship or New Glenn. So our goal, we are raising a $2 million pre-seed round. We are fully based in Florida. We strongly believe in the ecosystem of Florida. Living in Space Coast, I've seen so many amazing workers there. And given what's now happening with like NASA cutting down and other companies cutting down, there's so much just raw talent out there really wanting to work for an amazing, exciting company. And we've raised already an angel round of $100K from the 1517 fund, VC. And with the $2 million pre-seed, what we'd be able to do is invest much more heavily on the research and development to build out further the software and really work on the hardware. The hardware is going to be our highest cost point for capital, as well as develop a little bit of the infrastructure and operation, so paying employees and so forth. And our milestones in this initial stages will be testing out this prototype, as well as seeing if we can onboard a lot of these potential clients. Thank you. And I can take any questions now. Yeah, so Orbit Fab is the first mover here, and their port they've been working on is Rafty to work out with that, but it really hasn't been standardized yet because it's really new. Yes. Exactly. Yes. So we don't want Star Vault to use its own gas. So we are going to work with Avalanche Energy to incorporate their technology so that we just work off of the nuclear propulsion and deliver the hydrolysine to the spacecrafts. Yeah.
What's the schedule for your nuclear propulsion?
So that one is based a little bit more on the Avalanche Energy company's timeline as well. I've signed NDA, so I can't really talk about that one as much as by 2030, yes.
So I'm guessing because you're talking like hydraulics, like you was going to deliver,
Mhm.
right? So geosynchronous orbit, satellites. So I'm guessing that you are going to that.
Yeah, it's like a gas station on wheels that can also deliver the fuel. It's yes. Oh, sorry.
So a spacecraft can have instead of just doing it, you can attach it to say,
Yeah. Yeah, exactly. It's exactly that. And if let's say the fuel is still there and they need more fuel, we could stay attached if it doesn't mess up their orbit. But ultimately, the idea is attach, refuel, separate, wait for the next one until we're fully out of fuel, and then deposit the star vault into either a graveyard orbit or this is much longer term thinking, but using it as a way for space stations to take trash from like their self, put it in that unit, and then it goes into a graveyard orbit. So one thing I had heard from when I was working at Deep Space Logistics, when they're building out this logistics module, is that they wanted to use that module also as like something to store trash from the gateway and then have that go into the sun instead of a graveyard station. So this is stuff that NASA's thought of too. It's like it's really possible. It just needs as we've all talked about, social will, political will, and so forth. Yeah, all the way in the back.
Oh, yeah, good point. I hope you have a better competitive slide somewhere because when you showed, doesn't even show the main competitor. And there's a number of other companies involved. But these are points, don't you ever get any skepticism about your use of nuclear power? I mean, to me, that seems like a non-starter, frankly.
Yeah, so I'll go on the second point. So that's a great point. This is very ambitious, but as like all space is, like if someone were to come up to you and say, "I'm going to launch a rocket and it's going to land by itself," that's never been done before. So it's like you have to think of it in that way. And nuclear propulsion has been pursued to an extent. It got defunded by NASA due to political reasons. So a lot of this is technology that is technically possible. It just needs that push in order to make it happen. And the reason I work really excited about Avalanche Energy is because they're founded by someone at Blue Origin, who I know really well. They have that connection to the space industry. He's wanted this to happen. He just sees that providing energy to homes first is something much more possible. Yes?
Yeah, I wanted to take a moment to talk about competitive dynamics. I actually work at Starfish Space.
Oh, cool.
And I wanted to correct something.
Yes.
One of their main focuses is actually autonomous guidance, navigation, and control. So that maybe isn't quite the differentiator, as you said. But I guess I'm wondering, they already have 3 contracts, and as of today, they're launching a second demo vehicle. So I'm wondering, like, how do you catch up to Starfish Space?
Yeah, so that's the
Northrop Grumman, some other competitors.
yeah, so that's the Otter, right? So they've started their work in like what 2021. So we've had a few years, and it's they're still developing out tech and they're really based in an infrastructure. You probably know more because you work there, but because we're so new, we're able to build off of trends that are happening right now and incorporate new things that these our competitors are not able to do at this point because they're built in the infrastructure. Yes. We can take it out. So that is something that we'd like to have, but it's not a priority. What we'd say is really important for us is this autonomous navigation control. As I mentioned, we have Ava, who is her specialty is in computer vision and development of this type of software. So this is something that's really possible, and this can happen really fast. We're just working towards building out the funds and the infrastructure necessary to really build it out. Yes?
So I'm not an engineer, so I know this is a question, but every rocket or like multiple different types of rockets from what I know have different types of fuel. So like how would it work? Like will one you run out of reload in the Star Wars, like, do you launch one again? Like, how does the operation?
Yeah, that's a great question. So you're right, there's lots of different fuels out there. The way we'd have it work is have separate star vaults for different types of fuel, but we want to focus on a certain type of fuel first, really get it down, how the chemical of the gas break down the spacecraft and so forth, how to make sure that there's zero boil off, which means you're not losing any fuel as time goes on. And yeah, we would eventually want that star vault to go into a graveyard orbit or go to the sun. As I mentioned, one possible way we can use this without just throwing out a full spacecraft is to have it visit a space station, take this trash, and then go into that graveyard orbit. Yes.
In terms of the computer vision, which seems to be a big part of your technology, have you considered using flash LiDAR, which creates a point cloud that the computer can then process the Rothblatt docking, what Boeing Starliner used, and although that capsule had lots of problems, the Rothblatt docking was perfect. So have you thought about flash LiDAR instead of 3D video cameras? It seems kind of cool.
We're thinking maybe of LiDAR for the depth perception, but for the VLM, we really want to focus on the stereo camera, so that's optical light, to have the images necessary to identify where that docking is. But yeah, I agree that the rendezvous for the LiDAR was very, very good. Yes?
Yeah. To me, it seems like you're implying that your two competitors, which I posit are already kind of, already out there doing things, are totally ignoring because you're just AI in year 2025, and that only you guys are trying to marry it and vision systems, and that reduces the cost. And I'm just not accepting that as real. That your secret sauce that nobody else is working on.
Well, the thing is, I'm sure that they are. As was mentioned, Starfish is working on AI and using computer vision. But what we've done, and I've shown this in, let me find that. We've submitted a very proprietary workflow for enabling an autonomous computer vision software that differentiates itself from the competitors. It's hard to know exactly the differences here because everything's proprietary. This isn't like university, unfortunately, anymore. As a PhD, it's very sad. But yeah, to answer your point. Yes?
I see you were able to do 5-year additional life on a satellite that had 15. Is there a reason why you only did 5 years of development supply? And then second part of the question, is there an insurance concern here as far as
Mm-hmm. Yeah, that's a great question. So for the 5 years, there wasn't a specific reason. We haven't decided yet if we would do an entirely full refuel or if it would be partial. It would depend a lot on what the customer wants. So how many more years they'd like to have on their spacecraft before they think that the spacecraft itself would just break and then they realize it's not even worth refueling. And for space insurance, that's an interesting point because I've talked to several companies or people that are working in the insurance field that are trying to work and bring this to the space world. It's just that one failure costs so much money at this point that they have to figure out the numbers, better understand how much premium to charge, and so forth. But yeah.
So the other parts you might add to that would be like inspection, if there's an integrated function or anything, then perhaps repair.
Yeah, like Astroscale does a bit of. It's something like you want to do everything at the same time. I've found that the refueling is like something so urgent because of getting to Mars specifically, and NASA's focus and the White House focus on putting $1 billion to that. Like you literally, no one can get there.
I'm a strong proponent of developing those.
Yeah. Cool. Yeah. So we can talk later. I want to talk. You?
So as a few weeks ago, First Research launched
wow.
from Blue Origin and how we don't make that possible. And thank you for the question about how do you avoid getting your gas station to stock diesel when everybody else thinks the 87 unleaded, whatever it is. And you said one thing that I was frustrated with your assumption. You don't want to use the hydrolysate that would be intravenous. And when you're looking at integrating and relying on a new technology, maybe hydrology is what you want to use, because then you have these modular systems that you can repeat, and you know they're workable. If that's the one thing that keeps you from getting this done, getting the stuff up there, then that might be the solution that works now. And you might flip it later, or you might end up using the nuclear power on for it in politics. So I just noticed that because you said that, maybe play with that assumption just a little bit, so you have one thing to
Yeah, that's a great point because, yeah, we don't want the nuclear propulsion to end up being the thing that stops us. So part of the idea, like the focus really is the refueling and making this autonomous. So by being modular, as you said, we'd be working on a separate engine that can just move it without any need for nuclear. But yeah, thank you. Any other questions? Okay, thank you so much. I should give you this back. I have
Check, check.
We could probably use that mic. Yeah.
There's a switch on top.
Right. This. Hey Dave, can you duplicate it again because it's on the one? Yeah. 1 second. Let me get you introduced and we'll set up here. All right. We are preparing for the last of our three presentations. Feel free to step up, stand up, shake out, and prepare for this last one. If you came in during one of the presentations and have not received a ballot, please raise your hand. So we got a few in the back with no ballots. Rod is coming around, get you some ballots and some pens. And thank you. Yes. All right. So fascinating. And again, thank you to our contestants and thank you to everyone here in the room and the great questions that you're asking. Very engaging questions from everybody. and we really appreciate that. All right, so we are just getting reset here. It looks like, yep, we've got our present. Not yep. I'm gonna keep. Excellent. All right. Well, so after we are done here, after this next presentation, we will collect the ballots and they will be counted. And then tonight at dinner, at the dinner, we will be presenting the order of finalists per your ballots scored here today. Excellent. Thank you, Dave. All right. Okay, so our next presenters also their first time appearing here in the Rothblatt Space Settlement Business Plan Competition. Anjan and Nico, thank you so much for the work that you've done to present here. We're excited to hear from you. And Radiation Protection Solutions. So we've got to actually, it's great. We've had a very diverse set of business plans competition. 3 very different business plans addressing very different needs for advancing human space settlement. So let's give our next contestants a round of applause. Welcome, Radiation Protection Solutions, Anjan and Nico.
Make sure we have this clicker thing sorted. Okay, here we are. Oh no, I guess we don't have it sorted. Okay. I think that should probably work. Anyways, good afternoon, everybody. My name is Anjan.
My name is Nico.
And today we're really excited to be able to share with you our business plan. We think this business is going to be really important to the future of human space settlement, and that business is Radiation Protection Solutions Incorporated. So first, just a little bit of background on us. That's me on the left. Currently a junior at Georgetown University in the undergraduate program. That's up in Washington, D.C. I study international relations, so fundamentally coming from a non-technical background here. I'm also involved in the student space scene with SEDS USA. I highly recommend you check them out. And my day job is that I work at a national security strategy team at the MITRE Corporation.
And then I'm on the left there. My name is Nico Baumann. I'm a junior at Georgetown University studying economics. I also do financial analysis for Ziba Investment Group, and as was mentioned, I am part of the BD team at Starfish Space.
And with that, we're ready to get into the issue that's really been troubling us. And that issue is that we will never build O'Neillian settlements. Obviously, I'm not going to stop there if we can't protect ourselves from radiation. So that's a problem. We will never build O'Neillian space settlements without comprehensive radiation protection solutions. We do not have the kinds of comprehensive and effective radiation protection solutions to prevent us from drastically reaching fatal lifetime exposure to cancerous radiation if we were to live out in deep space. This is the kind of thing I like to think of as a zero multiplier on human space settlement. That means that we can invest billions of dollars into creating human space infrastructure, but without developing best-in-class radiation protection solutions, it would all be unlivable in the first place. And that brings me to the current state of space radiation shielding. It's important to understand that there are 2 types of radiation that we frequently encounter in space. We have solar particle events, which are sporadic, highly penetrating radiation bursts emitted by the sun, and we have galactic cosmic rays, which are omnipresent, low-intensity background radiation that slowly builds up over time. Of course, both are deadly in their own ways. We have 2 current types of ways to protect ourselves. Active protection techniques involve generating some kind of electromagnetic, so either a magnetic or electrostatic field that deflects radiation, and passive protection techniques involve usually putting up a hydrogen-rich or aluminum physical barrier that slows down high-energy radiation. Both of these techniques have their shortcomings. Active techniques use a lot of energy, especially if they're kept on all the time to deflect against the constant barrage of low-intensity galactic radiation, GCR. It's also, as you might imagine, pretty expensive to build such a system. Passive barriers are just as heavy, especially if you're using enough material to break down intense solar radiation. They add a lot of mass to spacecraft, and mass costs money to launch. So the elegant solution is to combine active and passive techniques into one integrated service or product. Rajashree Chowdhury and her colleagues at NASA published a comprehensive study on this in the August of 2023, where they compared layered shielding methods with just pure passive barriers. I won't bore you with the technicalities right now, although feel free to bring it up in Q&A. I'll try to answer the best I can with a poli-sci degree. But what I will show you is this graph. And there are two main takeaways that I want to relate to you. Firstly, adding an active shielding element allows you to reduce the mass density of your passive barrier by about 50%. Secondly, adding an active shielding component while keeping mass density constant increases total shielding capacity by about 65%. What that means in plain English is that whether you're going for cost effectiveness or maximum protection, Chowdhury's study shows us that a hybrid shielding approach is the way to go. And that brings us to the service that we want to bring to the market. Nico and I are looking to create a custom radiation protection solutions company that specializes in designing hybrid shielding systems. You can see this in the conceptualized diagram that we have here. We envision an active electrostatic shield sandwiched in between two layers of passive shielding materials with your human living space in the middle of that entire contraption. Now, we're going for an electrostatic approach here with regards to that active shielding part for competitive reasons. Boeing already has a few patents for hybrid magnetic shielding solutions, and Lord knows that's the last company that we want to upset right now. Now, of course, it's probably a little bit more complicated than this, but we envisioned the solution to require solving three technical challenges. And I'm sure our radiation expert will probably add on more to that in Q&A. But that will underpin how we build our business. Firstly, we want to be able to create lightweight, extendable systems made of our passive shielding material. We want to be able to pump high voltage power through our electrostatic shields, and we want thin film conducting polymer membranes that will be able to handle this power in the vacuum of space. So that brings us to our suppliers. We hope to work with composite technology development based out in Lafayette, Colorado, to develop our passive shielding systems. We're looking to partner with advanced conductor technologies based in Boulder for our power needs. And we're looking to contract Nexolve based out in Huntsville, Alabama, to source our conducting membranes. Once we've assembled our product, we want to be able to test it in a space-like environment, which is why we'll turn to the Magnetoaerodynamics and Aerospace Plasmas Laboratory, or MAPLab, I believe, located on campus at CU Boulder. Of the four organizations that we're looking to partner with, three of them are based in the Boulder area, which makes our choice of location an obvious one. We're checking out a warehouse in Lafayette that will put us within 3 miles of most of our prospective partners, with the exception of our Huntsville membrane supplier. Of course, based on our degrees and the fact that we haven't graduated yet, we're not going to be able to get this project off the ground without some great technical talent, considering, that we're not engineers. So because we're going to be based in the Boulder area, there's no better place to turn than Boulder's incredible graduate program supporting the aerospace industries already, based on the specific component systems that we need. We've anonymized our prospects here for their privacy, but rest assured, they're all some of the brightest minds in the industry. We're hoping to recruit an electrical engineer who got their master's at Boulder, is now working in Sierra Space, a material scientist who got his PhD at Boulder, is now working at a research group on campus, and a mechanical engineer who got her master's at Boulder, is now working at General Atomics. As a matter of fact, we are hoping that she would become our lead engineer and CTO because of her systems engineering background. Most importantly, these are all engineers with a specific technical expertise in the systems that we would have them design here at RPS. It's going to be hard to convince these talented people to go out on a limb and come work for us, but we're hoping they'll be just as convinced by the necessity of this mission as we are. And of course, we have plenty of backup options that we're looking to as well. Okay, so let's put it all together. This flowchart describes the major institutions, people, products, and objectives that we need to come together to bring RPS to life. In orange, we have in-house RPS employees. In blue, we have specific products that we need to design. In purple, we have outside suppliers and institutions that we need to interact with. And in green, we have objectives that we are looking to achieve. The basic logic is as follows. Our material scientist will partner with Nexolve to build conducting membranes. Our electrical engineer will partner with advanced conductor technologies to design our power systems. And our mechanical engineer will partner with composite technology development to build our deployable shields, as well as take the lead on integrating our systems with each other. That yields us a prototype product, which we would test at the MAPLab at CU Boulder. Once our product completes its rigorous testing process, Nico and I are going to throw the kitchen sink at selling this thing. We'll make sure to procure regulatory approval from the Office of Space Commerce under their new prospective mission authorization framework. We'll reach out to venture capital firms like Seraphim Space, Lux Capital, Bessemer Venture Partners, as well as venture arms of major primes like Airbus and Lockheed to raise funds. And we'll sell the product to civil, commercial, and national security space missions. Of course, it's circular. We'll use money from our sales and our venture backing to fund our contracts with our suppliers and pay our engineers competitive salaries. I hope by this point everyone sees the vision, understands the problem, and has a grasp on the technology that we're looking to develop. But I also threw a lot in there about sales, venture capital, and fundraising. I mean, who says this thing is going to make money anyways? Nico does, and he has the numbers to back it up. So with that, I'm going to turn it over to Nico to build the business case for this company from the ground up. Thank you.
Awesome. Thank you, Anjan. So my goal for this section is to convince each and every one of you that this is a financially sound business and an incredible investment opportunity. So before we start, I'm going to lay out a little roadmap. We're going to start by getting a total addressable market, or the total revenue opportunity for radiation shielding. Next, we're going to down select from there to get a market share, a realistic market share of what our company will be able to capture. And finally, we will construct a pricing model, a revenue model, and get to net income and a net present value for this business. All right, starting out with total addressable market, my intent here is not for you to scrutinize every line item. This is a very ugly graph, and that's not the point of this. Instead, what I want is our robust methodology, building from the bottom up a total addressable market for radiation shielding. Let's get to our pretty graph here. All right, so this is the radiation shielding market size. As you can see, we have very realistic growth assumptions based on investigations into each subvertical and the total mass to orbit, as well as the total radiation shielding required. As you can see, in our median case, we have around a 5% compounding annual growth, presenting a very attractive opportunity. And looking at our two core subverticals that we will be initially targeting for our services, which are crewed spaceflight and national security spaceflight, they have a $2 billion and $4 billion market size, respectively. Of course, just because we see a big market doesn't mean that our company will be able to capture that market. So let's take a moment to figure out what market share we will be realistically able to achieve. To do that, first, we're going to look at our target market and customers. So what we're doing here is we're taking a look at the actual verticals, programs, and companies that our company will be targeting with our services. As I said before, the first two subverticals we will be targeting is number one, human spaceflight. There's a couple advantages there. Principally, that is that the health and safety of astronauts is paramount, which makes customers a bit less price sensitive and more focused on performance, which our technology is optimized to achieve. The other main market will be national security. A lot of those assets are operating in high radiation environments. For example, the Van Allen belt in MEO, and also geosynchronous orbit. And again, these customers are less price sensitive and more focused on performance. So taking kind of a step down, what are the actual programs and customers we are pursuing? SpaceX, VAST, and Blue Origin are three massive customers that we hope to target. Of course, their vertically integrated mindset would present a challenge to any attempt to break into this market. However, we believe that even one of them, as these graphs show, would present an incredible opportunity for our business. Another human spaceflight market, of course, is the Artemis program. I'm sure you all know a lot about it. This is how we enable the future of human spaceflight. The vast array of contractors working on the Artemis program means that we have a lot of opportunities to break into this market. Of course, this program is already in kind of late design phases and is getting off the ground. So it will be hard, again, to break into this market. Next, we'll take a look at kind of the main national security-oriented programs we have here. So to kind of name a few, these are all programs that operate in high radiation environments and that have deployment schedules into the early to late 2030s. So we have the Evolved Strategic Satellite Communication System, the MEO Missile Warning and Tracking System, the GPS-3 follow-on constellation, and the new generation of the Geosynchronous Space Situational Awareness Program. All of these would present robust long-term demand drivers. So adding all these programs together, we're able to get to a serviceable, addressable market. That is the market that our solution, our technological solution, is specifically designed and optimized to deliver. So as you can see, we have in every single high growth, steady growth, and constrained growth scenarios, we see pretty substantial growth. And you see some, if you're wondering about the peaks, those are for the Mars transfer windows, projecting out SpaceX's ambitious plans. Now, let's take a pause here, because I think we all recognize that just because we are able to service this market, again, does not mean we will actually be able to get those contracts, that cold, hard cash. So let's take a moment to think about how we will be able to actually get those contracts. And let's talk about the competitive landscape. So broadly, we can bucket our competitors into two buckets. The first are our customers themselves, right? These big primes that are considering whether they want to outsource to a company like RPS or whether to vertically integrate their solution to avoid supply chain risk and integration costs. As you can see, we've kind of ranked a lot of the big systems, a lot of the big companies that we would be targeting. You can see SpaceX and Blue Origin, for example, are highly vertically integrated. So it would be more difficult to break into those kind of markets. However, for example, L3Harris mostly acts as a subsystems integrator. So they would be more attractive opportunity. Next, the second kind of main bucket of competition are our direct shielding competitors. For those, we're talking about Cosmic Shielding Corporation, STEMRAD, and Gould Orbit, all of which work on passive, active, and personal radiation shielding solutions. Now that we kind of understand our customers and our competitors, we can down select from our serviceable addressable market to our serviceable obtainable market, our SOM. Essentially what this means, the graph on the right here, is essentially the portion of the market that we actually believe we will be able to obtain. Obviously, it's smaller because we understand that some companies will choose to vertically integrate or go with a competitor. And again, you can see that we're pretty conservative with our estimates, and we project that it will take time for our product to gain traction and flight heritage. All right, so before we can get into our revenue model, we have to construct a pricing model, and I'm gonna, again, save you from these scary graphs and move on to our visual representation. For our pricing model, we opted for value-based pricing. What that essentially means is that we are pricing our product based on the value that we are providing to our customers. So we start with our base market price for ordinary radiation shielding solutions. Then we add our saved launch costs. That is a function of our incredibly mass-efficient solution that we are architecting. Next, we add the enabled product value. We foresee that our incredibly effective radiation shielding solution will enable new activities in space, whether that's improved health outcomes for astronauts, improved lifetime for computers and technology, or even entirely new experiments and activities. And finally, we're going to add the saved R&D costs because our customers will no longer have to spend money on developing their own radiation shielding solutions. And then we're going to subtract integration costs, the added costs of essentially deciding to outsource, because we don't feel comfortable passing on those costs to the customers. From there, we get to a total base cost, which we will sell to our customers. And from there, we get to our revenue projections for RPS. As you can see, in all three cases, we see pretty aggressive growth, but based on relatively conservative estimations. We see between 2030 and 2034 relatively kind of constrained growth due to difficulties in getting flight heritage and achieving market traction. But after that we foresee pretty explosive growth. From there, obviously, we don't only care about our revenue. Revenue always looks great on a graph, but we also need to consider our costs as well and our margins. So we took a look at our margins, and they look pretty good. So as you can see, we reach break even around 2033, according to our projections. And after that, in the steady growth scenario, by 2040, obviously, we're ambitious young kids, but we foresee that we will be able to produce around $370 million of net income in that scenario, in the medium case. Okay, so I've kind of brought you through all this. We got to our net income. How are we going to raise the money to actually go and fund this project? Mainly, that's going to be Series A and Series B VC funding. We foresee around $47 million in total, but we also want to lower our cost of capital and be efficient in our capital structure. So we're going to pursue SBIR and SITR grants from NASA and other non-dilutive sources of capital. That money will mostly go towards testing, personnel costs for our lovely engineers, as well as construction of our first manufacturing facility. And let's, finally, it's been a long road, but let's put it all together and get our net present value. Looking at our free cash flow to firm and using a 16.38% calculated weighted average cost of capital, we get to an after capital raising net present value of around $111.56 million, with an internal rate of return of around 20% in the median case. So I think after all this, you should be able to see that this is an incredibly sound and an incredibly attractive investment opportunity. We hope you enjoyed, and we thank you for your time, and we look forward to your questions. Thank you.
The first hand up was in the back over there.
Yeah, two-part question. First, to make sure I understood correctly, are you guys the only ones with a hybrid solution?
So currently, as it is, I believe that Cosmic Corporation is looking into building a hybrid solution. I think most hybrid solutions, as they were, incorporate mostly an active shielding component and then just a little bit of hybrid. But I think the studies that we saw showed that it is actually just more effective to have a pretty dense passive layer as well, just less dense than a completely passive layer.
Okay, and the second part of my question actually plays into that, because for the cruise application in particular, you realize that the degree to which you'll be able to apply the cruise solution, the customer will always have to look at, okay, if it's just 1 centimeter away from the active part of the shielding failing, and how bad is that? And, what would that have to do in that state? And what redundancy might or might not be able to be added, yada, 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 in terms of design trade. So, has there been any back and forth besides the company on that sort of trade?
I think it's a good point. I guess it does probably play into the idea of why a hybrid solution in general does act like that kind of stop loss. The other point I would make is that generally speaking, a hybrid solution would probably, for the most cost-effective way to use it, was probably to keep the active solution or the active component pretty minimal in its usage most of the time, and then turn it on when you have high radiation events like SPEs. Please.
So what I'm thinking at.
Well, that kind of comes to the part of us being a non-technical background. I think the best way of looking at this presentation of this business plan is that we have a study, we have a scientific study that we believe should serve as the foundation for a new business, but we aren't going to be the people that build it. And that we would work on this going off of this latest study, contract scientists or engineers who actually can build this out in a proper way, and then kind of take it back to you.
And just jumping off that point, I think kind of one of the main challenges a lot of space companies run into is that at the end of the day, like engineering is the most important part, but you also need that other component. You also need that sales. You need that ability to communicate, and I think that's what we bring to the table, and that's going to be a big important part of the problem. Yeah, definitely.
Sorry, just to address that question one more time. We actually ran into a small startup at Satellite this past year that was looking to build this exact same company, and they hadn't read the paper that we used to form the foundation for this. So they were also looking into radiation shielding, but I don't think that they had that latest piece of technical advice. So that's kind of where we're going. Please.
Okay, do you have any idea what the potential mass of something like this looks like? I mean, I'm sure your customers in the next decade aren't accounted for your system. And you know, a lot of, especially for Artemis, are looking at shielding the people as opposed to the entire spacecraft.
Yeah, absolutely. So mass is a critical part of this venture, of course. The study shows us that you can get the same shielding capacity for about 50% of the passive material mass, and I would account for about another 10% with the active component. So think about a 40% reduction in mass. Typically, passive barriers, to my understanding, are about 20 grams per centimeter squared, and that we could reduce that to about 10 grams per centimeter squared with an active solution added.
And just to add on, we recognize that trying to jump into the Artemis architecture late would be incredibly difficult. So in our modeling, we don't include any revenue from Artemis. Yeah.
But the reason I add the density rather than the total mass is because these would be custom designed solutions. You can add it to a small satellite, you can add it to
I may add this. Can you tell us a little bit about the power requirements for the hybrid system?
Yeah, that's probably a bit beyond my pay grade.
I read that paper, so I'm curious.
Oh, okay. Quite frankly, I'd have to get up to you on that.
It's very important.
Okay.
Oh.
Yes.
So, you guys missed it, but what do you consider to be active shielding?
So active shielding is any way of deflecting radiation by creating like some kind of field, and that could either be a magnetic field or an electrostatic field.
Okay. So what passive materials have you considered? What are you selected, and why did you select which ones?
Yeah, absolutely. So there are many different materials that we could look into. I wouldn't make that decision myself until I had a material scientist on our payroll. But the main types typically tend to be either hydrogen-rich materials like polyethylene with water or aluminum.
More over there.
So this is an idea I've played around with. Do you know of any examples of the use of active shielding in space to date? I think one of the big concerns is that you're disrupting the other aspects of the spacecraft operation by generating this field. I'm not sure.
Yeah, so I mean, the best I can give you. Once again, I hate to keep hiding behind my polyethylene, but the best I can give you is that you would need to create some kind of Faraday cage and then disrupt that whenever you want to exit that.
So you're not aware of any perhaps that have attempted this to date?
Actually, no. I mean, this is pretty much.
So at Blue Origin at NASA, it has to review different types of shielding,
yeah.
And it's always in comparison to aluminum. I know you guys aren't doing the technical stuff at the moment, but like eventually, as someone who would end up having decided to use your product, some reference to how much better it protects the spacecraft with relevance to the aluminum, as well as how much
less fuel weight it adds and cost, because aluminum's super prevalent. Like it's very easy like to get. So often us radiation engineers be like, oh, put some aluminum on it, unless there's something really good.
Yeah.
So, and cheap and like easy to get.
Yeah, that's why I turned back to this graph in the study that we cite, if I can get back to it. Yeah. So this graph is actually showing you radiation exposure like to a human being. This is 20 grams per centimeter square of aluminum. This is 20 grams per centimeter squared with active shielding radiation around it. So it is the kind of thing where obviously right now where we are with active shielding it will probably be a bit more expensive, but it saves you the weight of launch cost, and it's also just better. I mean, this is the lowest amount of radiation that you would receive if that's your main target. Please.
Yeah.
Farming out a little bit in what's your business plan against Boeing or somebody that has economy of scale, and potentially source quite cheaper, and how was that going to
Definitely. So yes, this was kind of a key consideration when we were developing our business plan, our business model. We think one of the key headwinds we would face in developing our product is the risks of vertical integration and in-housing that we would face. As you can see, there are companies like SpaceX and Boeing that would be more likely to do in-house. However, we also think because our solution is novel, because we have better capabilities, as we just mentioned, that we will be able to break in to some of the contractors who are more willing to be a kind of subsystems integrator, if you will.
And one thing I would add on to that is, ironically, just our location. I think being based in a place that is so close to most of the people that we want to be working with would dramatically actually reduce the cost of initially building the system, as well as just like how easy it is to like bring people together and put them together.
One of the things you want to study or show on your blog, all your different slides, is, I think, a chart that shows you what the species of particles are. When you look at the spectrum, particularly the solar system, I think, I probably remember that paper, but there's a species called the energetic neutral particles. Right. And they cause storage and secondary and tertiary radiation. So where do you put your active shield? Is becoming an interesting question. And the general idea is, you first have the big shield outside and then on the inside. Probably not the case. Well, it's very interesting thing to think about.
Yeah, so the solution that we ended up going with was putting the active shielding component within two passive layers. And the reason we did that is because putting passive first and then active is better for SPEs, whereas putting active first and then passive second is better for GCRs. And so just combining the two and kind of getting the best of both worlds makes more sense. Now, if you look at the Chowdhury paper, you would actually walk away with a different conclusion, but getting into the nitty-gritty, we think the Chowdhury paper didn't use an appropriate methodology to actually defend that sandwich solution.
Yes, so happens good.
Yes, please.
Do you guys have any examples of people breaking into SpaceX or Blue Origin as far as the vertical integration opportunities? I almost feel that a good thing to explore for you guys as well would be to try to be maybe a competitor to like a VAST and creating an all-habitat system that you can become a customer of SpaceX to launch with, right? And then demonstrate your capabilities that way, because trying to integrate onto a Starship, I think is going to be impossible.
Yeah, so this is an excellent point. I actually did take a look at SpaceX's kind of integration percentages over time. They started out with around a 95% vertical integration. As they've expanded kind of their portfolio of products, we've seen that actually drop to around 75%. So they say it's one of the things they're most proud about, vertical integration, right? But if you actually look at the numbers, their vertical integration over time is going down. And so we see that as an opportunity. And again, we don't model SpaceX revenues in our revenue prediction. So it would be an added bonus, I would say. As for building our own space station, I think, this gets back to like wanting to do everything. And I would love to do everything. And maybe one day. I would love to, yes.
If you guys want to test your stuff on balloons, just let me know.
Okay, we'll do.
Please, sir.
So you're both undergrads?
That's right.
Yeah.
Are you planning to take this into an MBA program?
We have a few people that are on the Georgetown MBA program, as well as some of our professors who are.
That would work well in the project.
Yep.
Yes, sir.
Have you spoken to the people at Meligen Lab? Do you know them?
Yes. So I believe Meligen is if I'm not mistaken, the 19-year-old kid from Embry-Riddle,
Yes.
and then
Yes.
yeah, that's the one. Yeah, that's who I was talking about.
Yes. Okay. You may want to team up.
Honestly, yeah. I mean, when I met them, I sent them the paper. I mean, I want this to be something that actually works for society and not just.
You have skill sets to find.
Absolutely. Very.
And you may have more proprietary technology than you have.
I mean, the guy is a 40-year radiation veteran, so yeah, I presume so. Thank you so much. Yes, sir.
Study the world, and you become aware that the major source of what are the major sources of ionizing radiation to living beings? Is it from outer space, or is it something within us, produced within us? Like, for example, mitochondria reactive oxygen species and protons, which are also ionizing. Do you know the relative contribution of those two buckets to spaceflight injury?
I'm not exactly sure I understand your question. Are you talking about where radiation comes from in space, or are you talking about how our body defends against it?
I'm talking about the latter.
Okay.
I'm talking about what are the major sources of injury from ionization?
So the primary organ that gets injured by radiation is the eyes. And we actually have more graphs in the chapter here that I can send later.
I understand that.
Yes.
What are sources of that radiation?
Like from space.
Any space, outer space, inner space.
Yeah. So mainly the sun is what produces the most intense forms of radiation.
Let's give a round of applause.
Yeah. All right. So as you're wrapping up your ballots there, I just think this is, I think this is our best round of the Rothblatt Space Settlement Business Competition. Thank you for your engaging questions. I was particularly thrilled to see, how many questions each of these teams had for each other. They were insightful. They were helpful. And I think it just really touched the theme of going together beyond diverse teams, diverse founders. Boeing, VAST, SpaceX, does not need to win a prize competition. So this is about developing new jockeys for the horse, new whys. There are companies out there that are doing similar things in similar ways, but this competition is developing founders that are doing this to achieve the goal of life and civilization of space in our lifetime. And so while there may be a company out there that has radiation technology, on the shelf, they don't necessarily, have the team, have the desire, have the insight to get it, into these applications as each one of these teams are doing in each one of their verticals, for this specific reason, not just for profit, but for to advance the cause of human civilization in space. So let's give all three of our contestant teams a round of applause. All right, so we'll be collecting the ballots on your way out, and there is a silent auction open downstairs in ballroom F, and